All right, this week we are going to now bring together what we've learned in the last couple weeks, where we're talking about building the atom and also about looking at the periodic table. So when you're doing these set of notes, you need to make sure that you have your periodic table out, whether it's the printed version or the online version that you have that you took notes on last week. All right, so we're going to put those together, all right, and start talking about how to draw the atom accurately. All right. Remember a couple weeks ago we talked about when we were building the atom, I didn't really care where those electrons went. All I cared about were the right amount. Starting this week, right, it's going to be really, really important that you understand where specifically all those electrons go, because that part is going to help us with what's coming up in the near future. All right. So it's really, really important that you understand this week's material, because we're starting to put things together and it's going to help us for the future lessons that we're going to have. All right.
All right, so here's the start of part two. So this is kind of where we ended up, where we talked about three separate groups that I wanted to highlight a little bit more about. You don't have to worry about the other groups as much at this point. I just wanted to do these three just because they're kind of like three most important ones, all right, as we go through. All right, now next thing we're going to talk about is how do we figure out how many electron rings an atom has. And I started talking about this last week, and I gave you some hints. It's actually pretty simple going through it, but you have to know how to read the periodic table to figure it out. And basically what it means is when you're drawing out the stuff. So for example, last week, right, when I said draw out lithium, all right, a lot of you guys did this. You made a little circle and you put lithium has 3 protons and whatever, and so many neutrons and stuff like that, and then you drew 3 electrons, 1, 2, 3 on there. And I said at the point, I might have said, well, that's correct in the sense of how many protons and electrons you have, but it's not actually accurate in the sense of how it should be written out, because really lithium should have, if I'm really drawing it out, I should have 3 protons, and then I should have actually 2 rings. I should have 2 on the first one, and then I have 1 on my last one. So I still have 3 electrons, just like drawn here, but this time I have 2 electron rings to do that. Now, how do you know when I should start a new electron ring? All right, and that's a really simple thing. It's basically which period is it on. So for example, I see that lithium, so if I do label my periods again, remember, periods are the ones that go across, right? All the way across, like this. Okay? If I look at it, hydrogen, helium are on the first ring, all right, or on the first period. If you notice, lithium, right, and I should have wrote lithium here so that way everybody knows that this is lithium, right, is that lithium is in the second period, or second row. Because I know it's in the second row, that's how many electron rings it has. All right, so electron rings equals basically, so to know how many electron rings it is, it's equal to the period number. And that's it. All right, it's really that simple. All right, as you're going through it, is to figure out all this kind of stuff. Now, on the next slide, I'll talk about how do you know how many electrons go on each ring. All right, because there is a specific number that we need to go off of, and that's called the valence electrons. All right, so we'll talk a little bit about that, but the idea is that you know how many electron rings an atom has based on where it is on here. So in other words, if I'm drawing francium, Fr right here, I just count 1, 2, 3, 4, 5, 6. It's in the 7th row, which means that it's going to have 7 electron rings. All right, here's another one. Let's go bromine right here, Br. All right, since Br is over here, I'm just going to count. Now this is the hard part because there's nothing above Br in the first one, so a lot of kids make the mistake in going 1, 2, 3. It has 3 electron rings. Remember, the first ring is hydrogen and helium. There's only 2 of them, so like there's that empty space. So you got to count 1, 2, 3, 4. So as 4, it's on the 4th row or 4th period. so it has 4 electron rings. Okay? All right, now this is where we go back into our notebook. All right, so now we're kind of done with drawing on the periodic table. All right, you're gonna tape that in at the very, very end after you're done with this. Okay, you're just gonna tape it in like you would normally tape in a quiz. Now, these valence electrons are the most important electrons, and they are, right, they are the number of electrons in the outermost ring. All right, that's what we were just kind of talking about in that last one. How do you know how many electrons go in the outermost ring? Well, it's because a ring is full when it has 8 valence electrons, or except for the first ring, which has only 2. And I'll tell you why in a little bit. And hopefully some of you guys kind of figured it out already, why it's only 2 in the first ring, okay, or and so on. And what we do is use the periodic table to identify the number of those valence electrons. Again, you're going to have to look at the periodic table. That's the reason why studying the periodic table this week. Ultimately, knowing the valence electrons, it's super important because it tells us how it's going to combine with other atoms. So when we talk next week about chemical bonding, we're going to talk about how those valence electrons helps us explain how it's going to interact with other atoms. Okay, but now, how do we figure out how many valence electrons? So how do we figure out how to put together and draw out our atoms correctly? And I'm going to show you, I'm going to go over how to do it, or how to find it, and then I'm going to show you its proof of why it works that way. Okay, so first thing is this. All right, here, going back to this. Now, I actually don't want you to draw on your periodic table. I'm just doing this because it's easier to show the periodic table and do the drawings at the same time. And yes, I want you to draw these out. All right, so let's talk about, so the first thing I want to go over and I'm going to draw out is sodium. And I'm going to show you that how you can tell the number of valence electrons. So the first thing is this. You're going to completely ignore this part. And I'm going to actually put a box around it so that you can't even look at it anymore. You are going to completely ignore this part right here. And I probably should have made it so that it's not, you can't see it. Oh, that is not what I wanted. Okay, so let's do this. Yikes. Let me get rid of that. Let's go back to this guy. I'm going to make it black right here so that we completely ignore this whole thing. You completely ignore the middle part right here. And you're going to also completely ignore this part right here. The only parts that you are going to look at are the first 2 columns and the last 6 columns. These are the only ones that matter when we talk about valence electrons. I'm not going to go into too much detail. This notes is already way too long when it talks about why these ones don't count for the outermost electron rings. If you really, really want to know, come see me, and I'm more than happy to talk to you about why that's the case. But really, you just need to understand that these ones don't matter. Now, on the last slide, I talked about how a ring is full when it has 8, or in the first ring, it's full with 2. And the reason why that's the case is because if I count, right, and I want you to count kind of with me, 1, 2, if I only count these, 3, 4, 5, 6, 7, and 8. There are only 8 columns that matter. Now, why is it that the first ring only has 2? Well, the reason why is because there's only 1 and there's only 2 atoms on the very first period. That's the reason why there's only 2 valence electrons. That's the reason why that first electron ring gets only 2. If you notice, if I count all the way across, every other one after this has 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's the reason why all the other electron rings ends with 8. Don't worry about this last one. This is actually an older periodic table that's actually full all the way to the end right here, all right, as you're going through. So anyway, everything counts to 8. Now let me show you how this works. All right, and how? Let me just give you some proof that this is really actually correct. And I'm going to show you two of them on this right here. I'm going to draw it out. So here's beryllium. All right, so I'm going to draw beryllium. Beryllium has what? 4 protons, right? So it has 4 protons, and I'm going to draw one ring, right? And if you look, it's on the second row, so it has 2 rings. So I'm going to draw 2 rings. And since it has 4 protons, it also has 4 electrons. If I do this, 1, right? And let me do this. Let me color code my electrons black right now. 1, 2. And again, the first ring ends with 2. It's full with 2. And then we go 3, 4. If I count now the number of valence electrons, so the outermost electrons, there's only 1, 2. There's 2 valence electrons. Beryllium is in the second column here. It's got 2. Let me do magnesium, the one that's right underneath it, right? So now magnesium, let's go back to this. So magnesium, right, has a 12 protons. So now I'm going to go like this, 1. And if I look, magnesium is 1, 2. It's in the third row. So I'm going to draw 3 rings, right? And since it has 12 protons, it's going to have 12 electrons, right? So let me show you that ultimately when I do this, it's going to come up with 2 valence electrons. It's got 1, 2, and then remember the first ring ends with only 2 electrons. And then we're going to go 3, 4, 5, 6, 7, 8. Now I'm doing it in this kind of order for a reason. 9. I don't expect you to know this right now. 10, 11, 12. If you just get rid of everything other than just look at the last ring, it's got 1, it's got 2. Just like beryllium, 1 and 2. So everything in this column ends up having 2 valence electrons, right? Now if I did this, and I'm not going to do this for time purposes, if I did this for every single column, and if you want to practice, you can. If I did the same thing, if I went to boron and aluminum, you would notice that I would end up with 3 valence electrons in the outermost ring. You would then notice that if I went to here and I did carbon and silicon, I would notice that I would have 4 electrons in the outermost ring. So that means I would have 4 valence electrons. All right? The important thing that you need to understand is that the middle elements, called the transition metals, don't matter when you're talking about valence electrons. So this is how I count how many valence electrons I have. And again, next week, being able to identify your number of valence electrons is going to be very, very important, because when we start talking about chemical bonding. All right, and then the last column right here, they have 8 valence electrons, so I would actually end up having a full outer shell at the end, except for helium. Helium would only have 2, since there's only 2 atoms on this row right here. Okay, all right,